On behalf of ASHTO, thank you for joining the ASHTO Safety webinar about how Ohio is using predictive metrics, including empirical bias calculations. I'd like to hand the mic over to Greg Olson to take it away from here. Thank you.
Awesome. Thank you, Ben. Hello, everyone. Welcome to our webinar today. We are excited to be here with you all again. Really excited about our presentation today. We've got a great hour here that we're going to learn a little bit more about what Ohio Department of Transportation is doing. Some kind of housekeeping items before we get into that. We are recording this webinar, so we'll make sure and share a copy of that out with everyone. As far as questions and interaction, as always, we'd love to hear your questions and your comments. We'd like to encourage you to drop those in the Q&A window, and we will be keeping an eye on that throughout the presentation. We've got some time booked out at the end to actually go through and answer those questions, but I'd encourage you to actually ask them as we're going through the presentation. There may be a topical question that actually we want to bring up right at that point. So feel free to hop in there and just start dropping those questions in the Q&A panel, and we'll make sure that we get you taken care of. As I mentioned, we've got about an hour scheduled out for this webinar, so we may end up with a little extra time here at the end that we'll give you back. So let's take a quick look here at our agenda. So we're going to, we'll do some quick introductions, and then we're actually going to kick over the bulk of our time here to Brenton from the Ohio Department of Transportation. He's going to talk to us a little bit about how the Ohio DOT has been using predictive metrics, including empirical Bayes calculations to improve roadway safety in the state of Ohio. Really excited about this one. We've been working with Brenton on this for a while, and he's got a great presentation put together for us. We're going to have a few minutes after Brenton's presentation for some Q&A, and then we also are going to take just a minute at the end here to review our recent release, the alternative design update that came out recently from ASHTO Safety. So let's go ahead and do some quick introductions. So our presenter today, we've got Brenton Bogard. He's the State Safety Engineer in the Highway Safety Program for the Ohio Department of Transportation. And he's going to be sharing a little bit with us about what Ohio has been doing for some predictive analysis. I am Greg Olson, and I've also got here with me Danny Anderson, our Vice President of Product over here at Numetric. Danny and I will kind of be handling the questions in the back end, running the webinar, and Brenton's going to kind of take it away for his presentation. So Brenton, we will go ahead and I'll turn off my screen share here, and we will kick the time over to you for your presentation. So thanks, Brenton.
I'm Brenton Bogard, State Safety Engineer in the Highway Safety Program at Ohio DOT. I've worked in various roles throughout the department for the last 15 years, the last 3 of which were in the Highway Safety Program. Over the last 8 months, we've implemented ASHTO Safety primarily as a tool to perform network screening, and I was asked to share our experience and how these tools fit within our planning process. So I will go ahead and turn my camera off for the rest of the presentation, just to make sure no issues, and advance my slides here. So the main topics I'll be covering in this presentation are how Ohio DOT is utilizing predictive safety analysis through a few of our planning processes, how we navigated establishing a network screening process in ASHTO Safety's platform, and then a few use cases of how we're utilizing the network screening output and how it fits into our processes. I'm sure many of you are familiar with the roadway safety management process, which I think kind of sets the stage for what I'll be focusing on today. The roadway safety management process starts with network screening, so it's critical for us to get this activity right as it feeds all of the downstream processes. At Ohio DOT, we've embedded predictive analysis into many of our safety processes and tools, including network screening, selecting countermeasures for project sites, performing economic analyses for different project alternatives, and prioritizing and selecting projects to fund. As I mentioned, for this presentation, I'll be focusing on network screening specifically, our goals in network screening, how we established our network screening analysis process, and how we're using those results. The purpose of network screening is to identify and rank sites where a crash reduction can be realized with the implementation of different countermeasures. But it's not just about reducing crashes. Along with many other states, Ohio DOT is a big proponent and focused on safe system and safe system roadway design hierarchy. So we really want to focus in on reducing fatal and injury crashes. With the Highway Safety Manual methodology and safe system approach in mind, we established our site ranking metric as expected fatal and injury crashes. So we want to find those sites where we can make the most impact with the funding we have available. It's very important for us to establish our ranking metric up front, because everything we did from that point forward in setting our data up in Ashtaware's safety platform and all the decisions we made along the way were made with the goal of being able to calculate expected fatal and injury crashes. Sorry. So it's kind of a little daunting to start. Another important reason to know exactly where you want to end up, and to end up with expected fatal and injury crashes, we know we need safety performance functions, or SPFs. To develop SPFs, we need to know our different site types. What sites are we developing SPFs for? And to develop SPFs for different site types, we need crash and roadway data. And we need to know if it's rural or urban, divided, undivided, how many lanes, it's ADT, traffic control, etc. So that first step is getting crash and roadway data set up. We got our roadway LRS, provided AADT, intersection and some asset data, and established an API connection to transfer all of our historical crash data plus our current year's crash data. And that lets us update crash data weekly, daily if needed, but really builds that base of crash data. For the purposes of network screening, we're using the latest 5 full years of crash data. So I mentioned our ranking metric, and we use that to rank both segment and intersection locations in rural, urban, and suburban settings for a total of what we call priority lists, a total of 8 priority lists. The separate priority lists ensure we're getting good representation of all the different location types across our districts and our state. So for intersections, we're generating separate rural, urban, and suburban intersection lists, and that's similar for segments with the addition of separating out freeways from non-freeway segments. Determining subtype groupings for SPFs can be an iterative process, but luckily for me, our office had a history of using safety analysts, so we have an understanding of our intersection and crash data and a good idea of what was likely to work. But essentially, we're trying to get to the most detailed description of a site while still having enough locations and crashes to develop a reliable SPF. With the level of detail available in our roadway and intersection data, we can split our intersections up by locale, divided, undivided, control type, and number of legs. So for example, one intersection subtype would be for an urban undivided 4-leg signal. And for a segment example, we would have rural, non-freeway, multi-lane, divided, something like that. So with all the different combinations of subtypes, we ended up with 56 intersection subtypes and 26 segment subtypes that we could create, potentially create SPFs for.
Hey, Brenton.
Mm-hmm.
Sorry, if you could go back one slide.
Yeah.
We had a chat come in that I actually think is a pretty relevant
Sure.
question for this slide right here. The question was the HSM defines only urban and rural areas.
Mhm.
What definition did Ohio use for suburban areas?
That's a good question. So number one, we thought it was worth separating out because of how different those sites can be and how they operate and crash data and things like that. But we used a couple different things. We looked at if it's in an MPO, if it's with an urban area, but our tech services team, our roadway data team, they have a suburban layer that they specifically use. So we primarily utilize that, and I can follow up with a more
Yeah.
detailed description of the different filters we use to
Yeah.
define suburban.
No, that's perfect. Thank you. Thanks, Brent. I know that's we've seen suburban come in occasionally. And so I know it's not common across all the states. So thanks for
Yep.
kind of explaining it a little more.
Yeah, it's one of those things where we have the data available, so we went ahead and utilized what it was, but I don't know the specifics on how they separate out suburban from urban.
Sure. But
But it is,
you've
but
seen a
it is
pretty
a
good.
subset. Oh, sorry.
Oh,
It is a subset of the urban data. So rural and urban is its own thing, and then they carve up urban to get suburban. Yeah.
oh, perfect. Awesome. Thank you.
Hopefully that's helpful. Okay. So I left off kind of, so we've got our subtype groupings. We're getting ready to create our SPFs, but there's some things we want to filter out. So before creating SPFs, we excluded a few crash types that aren't really a part of that normal everyday roadway conditions. So we excluded animal, work zone, and non-collision crashes before we went ahead and created our SPFs. So with those crash types excluded, our subtype groupings created, we can start generating our safety performance functions, which we have a nice dashboard here in Ash2R Safety's predictive analysis application to see a lot of important information to help generate and visualize the SPFs. The first thing we want to do is set our time frame for what years we want included in generating the SPFs. And as I mentioned, we're using the latest 5 full years of crash data. So crashes between 2019 and 2023 were included in our analysis for this year. The nice thing with this is, next year when we go to do it, you just update the time frame and it filters your crashes to your the years you want, and you can recreate the SPFs again. But from there, we use the different drop-down options to narrow in on the specific SPFs we want to create. So first, we're choosing segment or intersection, and then rural, suburban, or urban, and then its subgroup type, which is the various different combinations of number of lanes, divided, undivided, or control type. And then for every one of those subtypes, we have the option of creating an SPF for 2 different severity groupings, one for all crashes and one for fatal and injury crashes, which is how we're going to get our ranking metric of expected fatal and injury crashes. To make sure we are creating reliable SPFs, we want to check to see if we have enough sites and crashes in our subtype groupings. So I think you can see these stats within the application itself, but you can also download a report, which is what I'm showing here, a piece of our intersection list. And we set our minimum number of sites to 50 and number of crashes to 100. If a subtype met those criteria, we then generated the SPF for that subtype. There were a few exceptions where we created a few SPFs where we had enough crashes, but maybe just under the number of sites, but we felt it was an important enough subtype that we wanted to go ahead and create that SPF. Within predictive analysis application, there are features to help identify the best statistical model to generate each SPF. There's a matrix that breaks down the different methods and models and which one fits your data the best. But if you're anything like me, that's very much outside of your area of expertise, fortunately, there's also what I like to call the easy button option, where you just set the function and over dispersion factor to optimal fit, let the application choose for you. So we definitely wore that button out in creating our SPFs, but it's not something we just did blindly. We tried different model types on different subtypes and made sure that the optimal fit option was indeed consistently choosing the models that best fit our data. And we didn't stop there. We utilized FHWA's Resource Center, specifically Derek Troyer and the safety and design team, to compare AshToWare's prediction modeling to what other tools are generating to help validate our SPFs and provide us with a level of comfort and confidence in what we're generating. So safety analyst methodology and SPFR were both used to compare to what we are getting in the current AshToware safety numeric platform. And they were very similar, comparable, a lot of times within 0.1 crashes per year per mile in SPFR. So big thanks to Derek for his work in helping to validate our SPFs. With our SPFs created, we can start screening our network. For segments, we use the sliding window analysis application to set our window length, filter out intersection crashes, and then filter the data to only include the subtypes for whichever of the priority lists we were creating. An enhancement is coming, I believe, to sort by expected fatal and injury crashes within the application, but that currently didn't exist or doesn't exist. So we downloaded the data in table format and then sorted it from there in Excel to create and publish each of our priority lists. So you kind of see a snapshot there. Intersections was a very similar process within the network screening intersections application. We just need to filter to whichever urban, suburban, or rural list we were creating, download the data in table form, and then sort by expected and fatal and injury crashes. After we've created all of our priority lists, we publish those publicly to our webpage, which if you want to see what ours looks like, you can click on the link. I'm assuming these slides will be shared shortly after the presentation, or if you got a second, you can get your phone out and follow the QR code to our website, scroll down at the very bottom of the page, and then open the Excel file shown here in the image. And I'll just wait a second if people are interested in doing that, but you can go there, download our list, see what it looks like and all the different data that we provide there. But we also have links to, we then put it in to map form, but eventually we'll transition everything over to the AshToware safety platform. We won't have to do as much Excel work in the future. With network screening complete and our priority lists published, our district planning teams start reviewing and selecting locations to study. Local agencies also reference these lists in their planning efforts. With study locations selected, we can start to dig in on diagnosing the safety issues, selecting appropriate countermeasures, and performing the economic appraisals. And we use HSM spreadsheet tools to calculate predicted and expected crashes for proposed countermeasures and perform our economic appraisals as well. With studies and safety analyses completed, we accept funding applications twice a year for our more complex design projects like converting stop-controlled intersections to roundabouts, and we use safety data to prioritize those projects. So you can see here a list of application scoring criteria that we've crafted over the years to prioritize locations consistently experiencing injury crashes and whose countermeasures include proven safety countermeasures. In the last few years, we've really encouraged our district and local partners to submit roundabout project applications as one of FHWA's proven safety countermeasures. And based on Ohio-specific before and after crash data, we know that they work. We can confidently dedicate funding to these projects, knowing they will have an immediate and long-term impact on mitigating fatal and injury crashes. And since September 2022, we've funded 83 roundabout projects with HSIP funding. So definitely proud of that and looking forward to funding some more coming up soon. So the reason I mentioned those specifically is traditionally we would get to a roundabout alternative by reviewing the network screening priority list for locations to study, performing alternative analyses, whether it be through ICE or other similar processes. But with AASHTO Safety, we recently created for the first time a roundabout specific screening list for each of our districts. This will help save time and kind of cut straight to the locations that are ideal roundabout candidates and we know will score well in our application process and have a high chance to receive funding. So what does that look like specifically? We used network screening intersections application in AASHTO Safety and filtered crash types to left turn and angle crashes only, the types we know that roundabouts will mitigate. We've removed animal, work zone, and non-collision crashes again. We filtered down to undivided routes for this analysis because we're mostly looking for the single lane applications. We also filtered intersections down to those with ADTs less than 20,000 and where legs only had one through lane in each direction. Again, we're looking primarily for the single lane roundabout applications with this screening. And I was excited to see at the top of each of these district roundabout screening lists locations that were already in the process of being converted to roundabouts, signifying to us that both our statewide network screening and roundabout specific screening processes match expectations, and we're finding those locations where we can make the most impact. So excited to kind of expand on that in the next few years and start to zoom in on those roundabout specific applications and kind of cut some time down in our planning and filtering processes. Yeah, and to summarize and wrap up before taking some questions, Ohio DOT has embedded predictive analysis into almost every step of our roadway safety management process. From network screening through project prioritization. We're leveraging AASHTO Safety to complete or assist in most steps, primarily network screening, but we'll be expanding in the next few years. And we're starting to customize network screening methods to screen for locations that would be ideal for specific countermeasures like roundabouts. And we're also looking into what other countermeasures we can focus in on and screen for as well. So that is all I have. And I will turn it back over to Greg and the team for any questions.
Awesome. Thank you, Brenton. Fantastic presentation. Thanks for walking through kind of the groupings, all the detail, everything there. It was really well done. So I know you put a lot of work. So we had actually quite a few, excuse me, quite a few questions come in. So buckle up.
Sure.
The first one came in actually was, does your data include only state-owned roadways, or do you have the kind of locally owned roadways as well in your data?
We have state and locally owned data. So that was another kind of filter off the top that we did is specifically for intersections. We don't want to include in our screening, let's say the functional class 7, which is our local routes. We're not interested in local to local intersections. So we did some filtering of trying to find those more significant intersections. But yeah, we do include state and local data.
Awesome. Yeah, I know that's a big concern, and like, do you include it? Do you not include it? Is it going to mess the data up? Is it going to give you a bunch of white noise? But it sounds like being able to include it and then just filter that out because it's not necessarily relevant to what you're looking at.
Right. So we know those are never going to, rise to the top of our priority and our what we're interested in measuring. So we try to filter that out up front. And yeah.
Awesome. Thanks, Brendan. Another question. Before using the optimal fit function in Ashtaware Safety, who created your SPFs? And then kind of follow up to that, what advantages have you found with the optimal fit approach?
Sure. So creating SPFs was before my time. I mentioned I've been here 3 years, but we did use Safety Analyst. So Astro's tool at the time used Safety Analyst to create for our planning SPFs for network screening. That question fits.
Brenton, we lost your mic again. Sorry.
Yes. Can you hear me now?
Yeah, there we go. Perfect.
Okay, sorry. I don't know why it's my microphone today has been so finicky. But we use Safety Analysts to create SPFs historically. And the optimal fit is great for just saving time. And once you kind of establish what your data, what models fit your data best. So you can kind of go through what we did the first few SPFs we created. We're looking at how our data fits these different models. So you can kind of compare. But after the first couple, it was the same one, over and over again. So we knew the optimal fit was going to work. So it's mostly just a time-saving thing of because you're repeating that process for, what did I say, 70 some SPFs. And then the different severities. So multiply that by 2 for us. So time-saving thing, and from testing that it fits your data pretty good.
Nice. Awesome. Thank you. So one question, we had actually a couple questions come in around the kind of intersection segmentation data. So how robustly populated is your intersection and segment data in your line work? Specifically looking for producing SPFs, right? I know that's a challenge a lot of states have, is getting that data to a point where they feel like they can make SPFs from it.
Yeah, so I was lucky to have, when I stepped into this role, pretty robust intersection and roadway data. So that's something Ohio has worked very hard to have a pretty complete set of data. We're on top of all of our Meyer roadway data. So we have a couple 100,000 intersections worth of data, ADT, control type, lane data. Same with our legs, number of lanes, divided, undivided, and all that associated data you need to create the SPFs. That's something I've kind of just stepped into, lucky to have. But yeah, obviously that's a big factor in being able to not only create SPFs, but create reliable SPFs. But yeah, like I mentioned in the slides, it was definitely an iterative process of how far down can you filter these site types to still have enough sites and crashes to create a reliable SPF. So that's something where we were conscious of when creating the SPFs. But yeah, having all the different filter capabilities was very nice.
Awesome. Derek Troyer looks like raised his hand.
Oh no.
So I know, right? My guess is Derek wants to comment on this. So Derek, go for it.
All right. Can you hear me?
Yeah.
Yes.
Cool. Yeah, so I think Brent touched on a lot of this, but the two major things are essentially traffic control and volumes, right? And so Ohio, he had a TRCC grant to collect traffic control for all their intersections. And then I think for volume collection, there's a sampling process every 3 years for state roads, and I think approximately 7 years for kind of a local system data collection to estimate volumes on the local system. So there's a pretty robust count program to get traffic volumes across the network wide. And that really helped be able to predict crashes on these roads. Even if we're estimating a volume, it's a volume on that on that leg of the intersection.
Nice. Awesome. Thanks, Derek. Thanks for adding that kind of extra color to it. You're always welcome to raise your hand on our webinars. So,
Yes.
all right. We got one more question. Well, another question coming in. For your ranking process in your network screening, what metric or metrics did you use? Expected crashes, potential for safety improvement, crash rate? Which ones did you find yourself having the most impact and using the most?
Yeah, so this is expected fatal and injury crashes is historically what what Ohio DOT has ranked our sites on the network screening. So that's just going into implementing AASHTO safety. That was, one of our requirements. We need to be able to calculate this and rank our sites by this. So that was number one. We've done different network screenings or just different screenings or different queries and things like that where we've ranked by different things. We've had EPDO, crash rates. So it just depends on what you're looking for and what you're screening for. But yeah, for our big priority lists, we've traditionally, and for this exercise, used expected fatal and injury crashes.
Awesome. And kind of related to that, Jim Markham asked the question, and it sounds like this kind of addresses that, but I just wanted to kind of reiterate it a little bit. So does Ohio consider A severity crashes significantly different from K severity crashes? It sounds like you're kind of collectively referencing K and A crashes kind of as one kind of entity. Is that a fair assumption?
Yeah, we actually combine. We weight K's and A's together. But I mean, for this calculation, it's either fatal crash or not.
Brenton, I'm sorry, your microphone just cut out one more time. I apologize.
How about now? We're good?
Now it's good.
Okay. Yeah, so we weight the K's and A's together. Like I was saying, for expected fatal and injury, it's either an injury or not. So it would be counted in that or not. But for anything that's using like a dollar amount or a cost, it's we weight those together. So it's yeah, so the K's aren't jumping way up.
Sure. Awesome. Another question. Really good and organized work. Congratulations.
Oh, thanks.
Right, it's always nice to be complimented. 2 questions here. In Ohio, how are crashes flagged as intersection related? So what's kind of your process for defining, what crashes should be counted in part of that intersection analysis?
Yeah, I think we just have different filters for our LRS or roadway network on what is within that boundary range of where you have cross points at the intersection. And I don't know all the behind the scenes code to get those flagged, but yeah, there is a process to say if it's within these distances or this measurement, then it's flagging as intersection. And our crash reports also have, intersection related or indicated. That is also another check to say an intersection, and then we can try to tie it to an intersection from there.
Awesome. And then follow-up question to that. Do you also apply this kind of predictive screening methodology to corridors in addition to intersections? Or, do you kind of have a different way of handling those?
Yeah, so I mentioned we do segments and intersections. For our sliding window analysis for segments, we chop it up into 0.3 mile segments. So maybe not a corridor, but we're trying to find pieces of segments, yeah, where there's, you know, those high injury crashes. But that, you know, you can modify that in the sliding window to whatever length you want to do different corridor analysis. But yeah, for our purposes, we used 0.3, and there's no logic to that number. It was just something we chose. Historically, we had done 0.1, just kind of felt it was a little small, but that's something we can tweak, you know, moving forward if we don't think that's working. But yeah, we used 0.3 sliding window analysis for our segments.
Yeah, I know that's actually a pretty, that's not uncommon for most people to take that approach as well. So it's always kind of comforting to see other people making that same decision, right?
Yes.
Got a question here around the roundabouts, kind of your approach to roundabouts. This says, are you mostly doing the mini roundabouts? And then do you have an average cost for those roundabout projects that you'd be, you know, willing to share with everyone?
I think we do have some minis, but I think those are more like through the locals, which we don't maybe get too involved in. So they do exist. We do have some, but that's not what at the state level we're getting too involved in. But yeah, it depends. Is a good answer on the cost, right? But I'd say through our program, you know, we have a $5 million max that we give to any individual kind of our high dollar projects. But a lot of our roundabouts are kind of in that $2.5 to $4 million range. Any more to maybe 3 to 4, 4.5. But yeah, it just depends on how complex it is, if you're getting into right away or not. But I think that like 3 to 4, 3.5 to 4.5 is kind of typical to what we see.
Yeah. Yeah, and that's a good point on the mini roundabouts, right? Those tend to be better solutions and kind of, you know, a better environment for more of those local intersections, right? So another question, has Ohio DOT conducted any predictive crash analysis on freeways? And then just kind of, you know, follow up on that. What was your approach and experience with that if you did?
Yeah, that was freeways were included in our segment, the sliding window analysis I mentioned. So we separated out freeways from non-freeways. So that was kind of site types, subtypes.
Right. Brenton, I'm sorry, microphone.
No, yeah, please keep telling me. I apologize to
You're
everyone.
good.
This is like a today thing. So, yeah, we separated out freeways from our different site types that we created SPS for. So,
Brenton, sorry.
Totally different site type. Can you hear me? Can you hear me? Can you hear me?
Yep, there we go.
Okay, so yeah, freeways definitely different site type. In the next break I get, I'm going to switch my headset. But yeah, freeways are different. We created different SPS for freeways, different priority lists for freeways. We definitely wanted to separate those out.
Perfect. Thanks, Brenton.
Yeah, give me just a second here for the next question.
We'll give you a minute to change out your microphone. Did you want to do the?
Sure.
Yeah. So while Brenton's swapping out his microphone, let's actually kick it over to Danny Anderson really quick. Let me share my screen here. And Danny is going to just run through really quick our alternative design release update, and then we'll run back to Brenton with more questions. So if you've got more questions for Brenton, keep dropping them in the chat window, and we'll get you taken care of.
Yeah, cool. So we'd like to just do the release update with the webinars, and so while Brenton's switching over, we'll go over this. But the big thing to discuss with this most recently release is July 1st with the Ash to Ware catalog going online. We also were able to get alternative design up and out. So we're really excited about that. So for anybody who doesn't understand or doesn't know about alternative design, it is a tool that helps designers, especially with Part C analysis. so they can run empirical Bayes models on potential designs. This especially is targeted towards concept design, so it can be done very early in the process, or do things such as design exceptions, start being able to quickly say whether or not a design exception should be used in certain situations. So alternative design supports HSM1 right now, with the commitment of, as HSM2 models become available, they will be working their way into the application, probably before the HSM's fully released is our hope. This will also help our design friends as they are releasing Green Book Volume 8. We just got back from the Committee on Design last week in Portland. We're really supporting the designers as they are working to make a more robust approach to design, considering safe systems, considering a lot more things. Instead of it being a lookup table for designers saying, if this, do this, give them much more flexibility to be able to say, you understand the situation, you make the right decision, but we need you to give us quantifiable reasons and data to show why you're making those decisions. So this tool really is meant to help them be able to have those statistical analysis without having to go to a different part of the organization or agency to get someone else to run the analysis. They can do it very quickly when they're in their concept design phase, and they can run 3 or 4 concepts within a matter of minutes to understand what is going to impact safety on this roadway, what's going to give us our best return on investment, what's going to be my best benefit cost ratio. So we've really been out there speaking with groups, including at TRF, TRB, Committee on Design, helping raise awareness of the need and that this tool is out there. One of the things that you may have heard rumblings about, it's been in every TRB for the last 3 years, but as the HSM HSM2 Part C comes out, it's going to take those HSM1 models and it's going to only increase the complexity of those models. There are going to be more models, and the models that exist are going to become more complex. So the ability to have a tool that's simple and easy for designers to get up and work with is paramount for getting this up and going. So I just wanted to jump in and let you know, so this is up and going. It has all of the HSM1 models in, and with an eye to HSM2 as soon as we start getting those models from NCHRPs or different ways of getting those models. But if you have any questions about that, feel free to reach out. But
Awesome. Thanks, Danny.
yeah.
All right. Looks like we've got Brenton back. Brenton, you good? You ready to roll with more questions?
I think so.
We'll find out.
We'll see. Yeah, we'll find out.
All right. So we answered the question on freeways. Did we? No. Do you mind just hitting? I don't think we got the tail end.
Sorry.
So if you want to hit that one again.
Yeah, so freeways was something we separated out in our segment network screening. So we had everything else and freeways separate, obviously very different site types. So yeah, freeways, non-freeways, separate priority lists created for those. And we've kind of got away from freeways just within our safety program in the last few years. It's one of the safest functional classes, route types, and expensive. So we want to use our funding in other locations, but we do create those priority lists for our users to reference.
Perfect. Thanks, Brenton. Let's see. We got another question here. What fraction of Ohio's fatal and serious crashes are occurring on local roads? Yeah.
I know this. I think this is for. It's either for fatals or fatal and serious injury, but it's 60-40. You know, most of them are on the local routes. Yeah. So it's around there. I think that's pretty consistent throughout the country. But yeah, Ohio's about 60-40.
We got another, I think this might be our last question. So you can almost rest easy. Excuse me. How does the DOT focus specifically on bike and ped crashes? Do you have like a separate methodology for that, or do you feel that kind of your standard network screening model addresses those that crash population sufficiently?
No, this network screening model that I mentioned today does not address bike and pedestrians. So we take a totally different approach to that. We have a separate program for that, but we have a systemic program geared towards bike and pedestrian, where we do like a risk, and we did like a risk analysis on our network to find those roadway characteristics. So our systemic program is focused on roadway departure and bike and ped, kind of two separate branches of it, but same idea, same concept of analyzing our roadway and crash data for those risk levels of what are those criteria most commonly found in crashes involving bike and ped or roadway departure. And then we created like a risk level 1, 2, 3, 4, high priority to low priority of all of our routes, where we can systemically start looking at bike ped locations. So yeah, totally outside of this process.
No, that's good. And thanks for sharing that insight. I know it's a big concern for every agency, right? Especially with the high severities associated with those crashes. So thanks for kind of just giving a little peek into how you're kind of, fitting that in with your overall safety initiatives.
Yep.
Well, Brendan, I think we've reached the end of our questions. Thank you for taking just as much time to answer questions as you had for your presentation. We had a lot of great engagement, a lot of great questions coming through. So thanks for responding to those, and thanks for taking the time out of your day to share with all of us. I know this was, from my perspective, a fantastic presentation. I know it takes a lot of work to put into this, so it's appreciated. So thanks, Brendan.
Thank you. Appreciate that. And anybody, feel free to reach out to my email, and I can follow up with any other questions. And I apologize for the mic for cutting out for some of the time. So just one of those things, but I do apologize.
No, you're good. It's just not your day from a microphone standpoint. It happens. So awesome. Okay. Well, Ben, I think we are good, and we'll go ahead and kick it back over to you.
All right. Yeah. Thank you, everybody, for attending. And thank you, Greg, Brenton, Danny, for the excellent presentation and for answering questions during this. I hope everyone got something out of this. We recorded the webinar, so it'll be available to view later on. Thank you all, and have a great rest of your day.